Hi Algebra 1, my name is Miss Cope. If you don't know me, I teach Algebra 1 with Miss Brandt in the morning. I am doing the first instructional video for this unit, which is really exciting, but I wanted to give you guys a couple tips and tricks to be successful with virtual learning. So the first thing is when you're watching an instructional video, a lot of times the teacher or the instructor will tell you to pause the video and try a problem on your own. Please do that, because if you pause the video and you try it and then when the answers pop up on the screen you're correct, that means great, you're crushing it, you get it, you watch the rest of the video and continue to try that. But if you pause the video and your answers don't match up, then you know, hey, maybe this is something I'm not understanding. If you can't identify the mistake that you made, then you know I can talk to the teacher on call right now. This is where I struggled at 5 minutes and 4 seconds or whatever the issue is. But if you never pause the video and you never try, then when it comes to the test at the end of the unit and it comes to the learning targets, we're not going to have any idea of where you are, right? The teacher's not in your room with you or in your kitchen or wherever you're doing your work. So if you are distracted or you're just watching the video to watch it and you don't ever practice the skill on your own, right? Your teacher's not there to go around and kind of see if you are understanding it or not understanding it. So please, please, please pause the video and try the problems when the instructor who's giving the lesson encourages you to do so. So let's go ahead and get into it. Today is day one. We are adding and subtracting and multiplying, but basically only distributing polynomials today. I encourage you to do, please pause the video and try out these 4 problems on your own. I'm going to start going through them in 3, 2, 1. Great. So this first problem, what we're going to do is we're going to start by looking at the very first term. And I have a negative y. And I want to look at the rest of the expression to see if there are any other terms like that. And I see that there's a positive 9y. So I'm going to take those and I'm going to put them next to each other and I'm going to combine them because they are like terms and they make 8y. I'm going to go back up to my original expression. I'm going to look. There's a positive 5. There's no variable on it, so it doesn't have a like term. I just bring it down. So my simplified expression is 8y plus 5. Now look at my next one, 4x squared. I'm looking in that expression to see if there are any other like terms. I don't see any. I'm going to bring that 4x squared down. My next term is 2x, and I'm going to look and I see that there's a positive x in there as well. I'm going to take those two terms and I'm going to bring them down together. That 4x squared doesn't have any like terms, so it's just going to get brought down to the final answer. 2x and x together makes 3x, but when I look at the original expression, I still have this -6, this -6. I bring that down. There's no like terms with it, so when I bring it down to the end, I have 4x squared plus 3x minus 6. Let's go ahead and look at our perimeter and area problem. So we have a rectangle here. Just a reminder, perimeter is all the sides added together. So the length and the width added with the other length and the width. So we're going to take our perimeter, 12 plus 5 plus 12 plus 5 gives me a perimeter of 34 inches. So that's the length around the side, all the sides added together. Then to find area, we take length times width, and in this case that's 12 times 5, and so our area is 60 inches squared. All right, and then the table on the left side, this is something that we have not talked about. So if you haven't taken a moment, see if you can identify what the word degree means based on the columns that are provided in the information in each column. You'll see that the degree of 4, all of these have a an exponent of 4. But they have other exponents. To have a degree of 4 means that the greatest exponent in the equation is 4, and then it descends from there. So this is 4, and then an exponent of 1. This is 4, and then 2, and then none. This one, degree of 3, exponent of 3, and there is an exponent of 2, but the greatest is 3, so it's to the degree of 3. This is 3, this is 1, this is none. So degree is basically the greatest exponent of an expression. Term is something we use to represent the number of parts of an expression. They're all separated by a plus or minus. So for example, this has only one part. There's nothing in front of this negative symbol, so this is one term. This has 2 terms. It's one term separated by a plus or minus, second term. This is 3 terms. One term separated by a plus or minus, 2 terms separated by a plus or minus, 3 terms. One term, 2 terms, 3 terms. That's our warm-up. Go ahead and get into the lesson. We are going to look at these 2 expressions. One of them is asking us to add 2 things together, and one of them is asking us to subtract some things. So this one is asking us to add. It gives us a term, and it wants us to add these 2 parts to this term. So what I know is I'm starting with this term, and it's asking me to add x. It's also asking me to add a -1. And so I'm just going to simplify my signs. I know 5 plus x is the same, but adding a negative is the same thing as subtracting. And now you can see that this expression looks very similar to the ones that we did on our warm-up. So my 5 being my first term, is there any other terms that are like that? I can see that -1 is. So 5 and -1 together makes 4. And then if I look at my next term that I didn't use is positive x. I know those are not like terms, but we do want to write it in terms of highest degree. And this one has no degree because there's no variable. And this has a degree of 1. So we're going to write that x value first and then the +4 second. So this one is pretty similar, except we have a minus sign. So we have to treat that first. So we know we're taking 5, we're subtracting x from 5, and we're also subtracting -1. I'm going to take a moment to clean up my signs. 5 minus x is the same. And then subtracting a negative is like adding. So I'm going to start with that first term, 5. Any other like terms? +1. 5 and +1 together makes 6. I'm going to go back and I'm going to see I didn't use this term. So I'm going to drop down because it doesn't have any like terms. Just like this one, I want my one with the highest degree to go first. This variable has a degree of 1. There's no variable here, so it's a degree of 0. So I'm going to put that -x first and that +6 second. We know we're taking this first part and we're adding something to it. So I'm just going to start by rewriting my first part. And I know I'm adding a 5x to that, and I know I'm adding a +1. I'm going to start with the first term, see if I have any other like terms. I have a +5x. 2x and 5x make 7x. Then I'm going to go back to my original and look at my next term. I've got a +6. Any other like terms? A +1, a +6, and a +1 make a +7. I don't have to rewrite because my highest degree is first. So this is my final answer. Starting with this original 2x + 6, and I'm subtracting a 5x and I'm subtracting a +1. I actually don't have to do any sign cleanup, so I can just go straight to looking at my terms. Start with my first term. I've got a 2x. I've also got a -5x. When I put 2x and -5x together, I get -3x. I also got a +6 back in my original expression. Any other like terms? A -1. A +6 and a -1 make a +5. The terms are in highest degree. There's no other like terms, so this is my final answer. So what I'm going to do is I'm going to rewrite this below because this is what's being added to it. So I'm going to add that x, and I'm also going to add that -8. Now this new expression requires some sign cleanup, so I'm going to keep my 3x squared, no change, -4 plus x, and adding a negative is the same as subtracting. So now I can actually look at my terms and see if I can simplify. I've got a 3x squared. Any other x squareds? No. And then I'm going to look at my next term. I've got a -4. Any like terms? I've got a -8. -4 and -8 together makes -12. And then my last term is a +x. No other values that have that same thing. And this doesn't need sign cleanup, but we have our highest degree as 2 being first. But then our next highest degree is this x value, so we actually have to simplify or rewrite it to have our degrees in order from greatest to least. So 2, 1, and then none. So this is actually our final answer. These two expressions are being subtracted. So I'm going to start by writing my first expression below. And I'm subtracting x to the third. And I'm subtracting -8. I've got some sign cleanup I have to do right here. So I'm going to keep the 3x squared -4 minus x to the third. When you subtract a negative and a negative become a positive. So I'm going to begin with that first term. I'm going to start with that 3x squared. I don't have any other terms like it, so I'm just going to bring it down. I'm going to look at my next term, that -4. That +8 is a like term. -4 and +8 make +4. My last term is that -x to the third. There's no other terms like that. -x to the third. And now I don't have my degrees in order, so I have to put my highest degree first. In this case, my highest degree is the third value here, x to the third, so I'm going to put that -x to the third first. My next highest is the x squared. And then my next highest is there's no degree. So this is the most simplified version. And try these three adding and subtracting polynomials on your own. This is asking us to take these two expressions and these two polynomials and add them together. And this one is asking us to take these two and do something different. There's no plus and there's no minus. So if you've seen something like this before, you know that this really just means 2 times 3. And there's only one thing inside the parentheses here, so we take 2 times that one thing. But in this example right here, there is more than one thing in the parenthesis. So you may have heard this referenced as distribution before. We're just going to take that form, we're going to distribute it and multiply it by everything in the parentheses. 4 times 2x is 8x, and 4 times a negative 9 is a negative 36. We have our highest degree first, there's no like term, so this is actually our final answer. This one was asking us to add, which we practiced before, so I'll just do that really quick. So it's very important that you pay attention to what's happening between your polynomials, whether there's a plus, a minus, or there's nothing there, tells us we're going to multiply. Here's another example of the distribution in case you need it. So we've got 6. There's no sign there, so we know we're going to be multiplying, and we're going to distribute that 6 to everything inside. So 6 times 2 is 12. Then we've got x squared. 6 times 3, positive 18. Our highest degree is first. No like terms. That's our answer. Okay. So on the last one we looked at, we had just a number out here. We didn't have any variables. And so this one's asking us to add these two. And this one, there's nothing, so that means we're going to be multiplying them. So I'm going to start with this one. But this one is a little bit different. So there's no sign in between my two polynomials, so I'm going to be distributing. I'm going to be multiplying. 4 times 2 is 8. But there's actually an x and an x. And when we have variables that are being multiplied, we're basically saying x times x, which is x squared. You take the exponents of the variables that you had and you add them together. So I have 1x times 1x, which means now I have 2x's being multiplied. So x times x gives me x squared. And then 4 times negative 9 is negative 36, but I have an x, right, with an exponent of 1, and there's no x here, so there's a degree of 0. 1 and 0 together makes at least an x of 1. So we keep that there. Okay? No like terms, my highest degree is first. That is my final answer. Let's look at another one like that. I've got 6x, I'll do it in a different color. 6x squared times 2x squared minus 3. So I'm going to take this 6x squared and I'm distributing it to both parts. So 6 times 2 gives me 12, no problem. X squared times x squared. I have 2 x's times 2 more x's, and if you guys remember, I said when we multiply variables, we add their exponents. So x squared times x squared is going to be x to the 4th. And then 6 times 3, negative 18. I have 2 x's times no x's, means there are just 2 x's there. My highest degree is first. I have no like terms, so that is my final answer. All right, go ahead and try these 3 on your own. Hi guys, if you're seeing this, that means you made it through the first virtual lesson. Congratulations, so proud of you. There are a couple things that you could do right now. First thing, you could go talk to the teacher on call if you have tried the try-your-owns and they did not go hot and you feel like you need more help, or if you just want to say hi to the teacher on call. That would be great too. And your second option is you can go and do the quizzes that is due by midnight tomorrow, the 24th. You don't have to do that today. You can come back and do it tomorrow if you want. There's no lesson tomorrow, so the quizzes is attached to what you learned today. We will see you back here on Wednesday for the day 2 lesson. Bye guys.